Thank you for staying with me until the end. This is the last final section, which is lighting and rendering. So let's make things a little bit more pretty and call it a day. Let's make this seem a little bit more dramatic by adding fogs and lights, and also we're gonna start adding a lens effect. Usually this part I would do it with Nuke, but this is Unreal Engine course, so we're gonna do everything in Unreal Engine. So let's start. Alright, let me start with fog first. So let's go back to lighting level, exponential height fog. By default, it's using depth method, the cheapest method to calculate the fog. It's super light right now, so let's increase the fog density. So let's get out of camera for the better visibility so that you see easier. Okay, so as name suggests, this fog is based on the height. It's kind of hard to see, so increase the fog density to like 2 and increase the fall off. And if you move around, you see the fog is based on the height. And also, if you decrease the fall off, you see more gradation in between the fog and the rest of the world. And if you decrease the density, you will see less fog. So it's pretty simple and cheap method to calculate the fog. But what we are interested in right now, it's not this method to calculate the fog. It's cheap, but what we are after is volumetric fog. So I'm gonna revert this, go back to camera, and for now I'm gonna turn off Niagara effects. So if you go down exponential height fog in a detail panel, let's go down, 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 you see volumetric fog. If you turn it on, so the calculation method will change. Now, in the scene is basically covered with voxels, and what we can do with this is I think it's more accurate method to calculate the fog, and B, we're going to be able to start introducing the God rays. In this case, in order to make the God ray work, you have to, first of all, let's increase the extinction scale. For the better visibility, go to the light source, especially in this case, directional light and other point light or some local lights behave a little bit differently. But in this case, directional light, which is the sunlight, we go look for shaft. Turn on light shaft occlusion, and immediately you start to see the God ray coming in based on the position of the sun. So this is pretty cool. Unfortunately, from this camera angle, we don't see God ray much from the sun. So we're gonna start implementing a fake God ray. So let's start introducing some local lights. So I dropped the rectangle light, essentially an area light. I want to make it more like a spotlight in this case. So in order to control, first of all, let's make it slightly bigger. So maybe 400. So I made it 400 width and 400 height. We have to make the radius bigger, and we have to control the angle of the lights. So first of all, I'm gonna increase the bonder length like so, and change the angle to make it narrower. For now, we don't see much, so we don't know what's going on. So let's do something. Let's increase the intensity like so I made the intensity to 100, and you start to see a little bit. And increase the volumetric scattering intensity. This is where you control the God ray. So you started to see the weird God ray. So this is where we control this, place it in the right place. Essentially, in this case, I want to fake the sun direction, so I will just put it there. It's too short, so let's make it longer. I made attenuation radius, which is how far do you want to affect it. And it's too scattering, so let's change the barn door angle and barn door length. Something like that. And let's go back and forth with camera and let's see. So it's really just a combination of these numbers, and we're trying to make some sort of like God ray kind of feeling here. So yeah, we started to see something, but it doesn't look like a god ray. Kind of looks boring, so let's start doing something more. So let's make a gobo here. So because we want to see some more gradation and also like a different line going on inside of the god ray. So let's create one material. So I went to get to cinematics, material, gobo folder, so that's I just created and made a material named gobo. So make this thing plain and using texture sample, it's called T-pairing mask noise. Texture coordinate node. And I'm gonna use this as a mask. So go to this gobo, change this blend mode to masked, turn on two-sided, hook arrow channel to opacity mask, and let's create contrast. Cool. So let's save this, create material instance. Let's create plane, apply the material, go to material instance, let's make more holes. And I want to place this right in front of light. First of all, let's change this plane name, gobo, and parent this one to rectangular light. To do that, just drag this one. So now it says we have to change this gobo plane mesh to movable, which is okay. So change it to movable and drag this one under rectangular light and zero out the transformation location. Go out from camera, see where it went. It's there, but it's kind of hard to see. So let's make this guy bigger. Okay, cool. Supposedly this gobo should obscure the light source, light ray. However, it's not doing anything. And the gotcha is go to settings, project settings, search for ray trace, and turn off ray trace shadow. It's not supported. And then go to rectangular light, search shadow, and look for cast volumetric shadow. Turn on. Now immediately you start to see more beams coming out of it. So right. So let's move them around to show it in the sequencer, the camera view. Having another viewport might be helpful. Having two viewports can be slow, so I will change it to unlit here to have less computational power. In order to look one viewport and then the other viewport away, if you click this one, both of them goes into this viewport. So I would just click this Cine Camera Actors, click this viewport here and here. It's just a matter of taste, and don't worry, we're gonna change that later. Actually, instead of doing that, in order to get away with the shadow problem, what you can do is we're gonna use light channel. So type light. So there's this section called lighting channel, and by default, everything's set by 0. Anything in the world in the channel 0 interact each other. So I'm gonna put this gobo out of 0 but 1. As soon as I do that, you no longer see shadow here. But we have another problem that we don't have the beam anymore because it's not interacting with the light too. So what we can do is go into rectangular light and add light channel 1 into the rectangular light as well. It's kind of hard to see, but now this rectangular light is affecting channel 0 and 1, and this gobo is 1, so it's casting this light beam as well. So that's the dirty little trick that we can do. Another thing we have to do as soon as possible is to lock the exposure. Create post-process volume, make it 0, 0. Search for Infinix and Unbound. So what post-process does, it's basically, it's like kind of like an effect on top of what you're seeing on the viewport. So it's like a filter, kind of. We're gonna turn on infinite extent. So by default, whatever the effect you're making in post-process will affect only inside of this box, but by checking this one, it's gonna affect the entire world. But right now, we're gonna change the exposure. So what's happening right now is if you go dark place, like especially here, it kind of adjusts to the brightness. And if you look outside, it's so bright, but if you go out, it starts to get darker. So this exposure is great when you're playing game, but it's pretty annoying when you're making cinematics. So we have to turn this off. So go post process, search EXP, exposure, turn on minimum max exposure, set both of them -1. Back to camera. Now no matter where you go, the brightness will not adjust. If you go darker place, it's darker. If you turn it off, the Unreal Engine adjusts the brightness, but we don't want that, so we're gonna turn it off by post process. One thing I forgot to mention is that in the exponential height fog and going to volumetric fog section, here's more control that you can add. So as you can see, you can change view distance. The more view distance you have, the more volumetric will take over the cheap fog that we had before. So we're gonna create 20,000. It's pretty dense. And then lower the extinction scale. So it's kind of like a density. Make this one a little higher. Maybe 2 is fine. And this scattering distribution, you can change how much fog interact. So if you go more value, the fog will interact on the light source side, and if you lower it, it goes away. Somewhere in the sweet spot like this. Okay, something like this, and it took me a long time to adjust it. Maybe the lighting, the fog color is a bit too orangey, so let's see if we can change that. Okay, something like this work. Okay, here's a recap. I have this exponential height fog. Here's the density. Here's the fall off. Here's the location of the fog. Turning on volumetric fog. Here's the scattering distribution. So I'm kind of swing it to the light source side. And I changed albedo a little bit bluer. Extinction scale is like this. You can boost it up or less. View distance is 20,000. If you have less, you will only see in the front, but I wanted to keep it to the fullest. And we have fake light set up on the left side. We have this rectangular light, very strong volumetric scattering intensity, to control the fog density, and we're faking gobo in front of that to have a little bit of nicer ray. I think for me, by default, it was pretty cut off here, so the quick fix on that was essentially rotate this a little bit this way. If the top face was perpendicular to the camera, it was cut off abruptly, so I just ended up rotating a little bit. Also make sure the project settings ray trace shadow is off and cast volumetric shadow is on the light source, and lighting channel is 0 and 1 from the light source because the gobo is only in 1 to cast a shadow on top of the rest of the geometry. Also, another thing I wanted to change is, let's turn these guys back on and go back to camera. Go to sky atmosphere and change atmosphere height to 5 kilometers. By default, it's set to 60 kilometers, which is like a normal distance from ground to the space. Suppose we are very high up in the mountain, so we're gonna decrease that a little, so we have a little bit like deeper blue in the sky. For me, sky atmosphere is pretty cool that you can change all the skylight settings, and if I wanted to make it like cloudy, a little bit like diffuse light settings, I usually go to Mie, atmosphere Mie, and then start increasing that to have like a little bit more like a diffuse cloudy day of feeling. You can also change the color of atmosphere by forcing art directing it. So that's sky atmosphere. It's all anything about the sky. And skylight is another thing. Skylight is controlling the bounce light coming from the sky by capturing the information around it by real time. If you want more bounce light into the shadow, you can change intensity scale. Let's say like 5, then you have a lot more bounce light coming off. But usually default settings is good because whatever in the scene is capturing, the skylight is capturing whatever in the scene, so it should be accurate. But when you need some art direction, you can sometimes tweak skylight as well. Let's now turn back on the Niagara effect. I actually wanted to change the material of especially the foreground fog, just to make it a little bit more prominent. Currently the fog in front and the fog on top of the buildings are using the same material, so let's separate them. Go into Niagara particle and click the material. So we can just have 2, just duplicate this, wisp FG. So let's use that instead. So go back to original parent material, and I made a mistake by adding value and contrast to the base color, but it was supposed to be on top of opacity because the color is white and the opacity is the one that's controlling the fading. So let's move these guys. I'm gonna apply them. Okay, so now it's way too much. So actually change both of them. I'm gonna rename this building. The building one, I want them to be default, and FG. Sorry, I increased the opacity a little bit. And also I wanted to emphasize the snow particle too. I was using here. Again, same thing, this contrast and value should have been in the opacity instead of base color. And actually select snow particle shader, turn back on two-sided. We don't need ray trace shadow. And also I'm not gonna use depth fade actually, because after testing I think we need velocity and we cannot use velocity with depth fade. So turn on output depth and velocity, apply, save. So we see a lot more particles in the air. Maybe radius is a bit too big, so we kind of have to tweak a little bit. It's okay to see a lot of particle in the viewport, because when you render, you kind of get obscured by motion blur. So let's keep it for now. And let's start adding some lens effect right now. I usually do this part in Nuke and DaVinci Resolve, but for those of you who don't have access to Nuke and DaVinci, I think it's a good idea to do it everything in Unreal, and it's actually quite promising and it's fun. So let's do it. First of all, I want to import LUT that I created in DaVinci, so you can just plug and play in Unreal. Right click a new folder, call it LUT, and drag and drop the LUT that I provided. Double click post process. So contract everything. Navigate to color grading, MISC, color grading LUT, and choose this guy. And immediately it goes really wrong. You have to change a few things. Go into LUT settings. Sorry, go into the LUT texture. MIP gen settings. No MIP maps. And then you will see it in a better way. And we don't want that compressed. HDR high resolution. That's it. So then immediately it started looking a lot nice. Your favorite teal and orange. And also a lot of times in comp we add a little bit of convolution, like a little bit of blooming effect. So we go lens, bloom. We don't want standard, we're gonna change it to convolution. And we're gonna change the intensity like 2. And convolution scatter dissipation to be like 4. So it's started to look a little bit more dreamy. This is a normal bloom by default, but I want it to be a little bit like subtle. This is without, this is with. We can also add chromatic aberration in Unreal. Chromatic aberration is a common lens effect that it occurs at the edge of the picture. You start to see this red and blue kind of hallucination, and we can fake that in Unreal. There's a chromatic aberration section. Let's make the intensity to 1. Start offset, I would set it to like 0.4. So it kind of occurs only the edge. Okay, started coming along. Light beneath chromatic aberration, there's a section called dark mask. I cannot distribute this one, but you can search from online, and you can search something like these guys. Essentially, I try to mimic when the snow particle or rain particle hits on the surface of the lens. You can kind of see these bokeh, and especially this kind of interesting shape happening. This kind of shape happening on top of the lens. So you can search online something like this, type like lens dirt or something, and you can utilize this one. Just hook this one onto dirt mask texture. I'll make intensity like 8, so that it's kind of hard to see, but you start to see the dirt mask coming in. It's subtle, but it's there. Also, something very small but very important, let's add film grain. So inside of post process, there's film grain tab here, or else you can search film grain here, type grain, and you should see film grain. Let's add film grain by just adding intensity of 1. Maybe it's kind of hard to see here. So you have this kind of grain pattern all over the screen. Usually you don't see film grain in the brighter spot. I would keep the grain in shadow 1, mid-tone to be 0.5, on the highlight almost 0, so 0.1, so that you will have a little bit more natural grain here. Grain is a topic that compositors go really crazy about it. I'll just keep it minimal like this for now. Also, I want to add everybody's favorite lens distortion. Go plugins. We need the plugins. Type for camera. And enable camera calibration plugin. Click that. Yes. And restart now. Go restart it. Lens distortion is especially visible when you are using wide angle camera. This camera is not that wide angle, but you should still have a little bit of lens distortion, and every single camera in the world have at least a little bit of lens distortion. No camera exists without lens distortion. That's one of those things that VFX artists are very peculiar about, and we're trying to make this barrel distortion, which is the most common type of lens distortion. Close this, go back to the level. Let's open level sequence, view from there. Now we're gonna add lens distortion. We have been adding effect from post-process volume, but for this particular effect, we have to go from the Cine Camera Actor. So click Cine Camera Actor, add, and search for lens. Literally add lens. Go to distortion. You can also set up lens file, but for this time, we're gonna just use manually. So go manual, and lens model to be spherical lens model, and just add a little bit, minus 0.2 on K1, right? So you have to click apply distortion. So immediately you start to see a little bit of distortion happening. This is the realism that we are talking about. If you go too much, you start to look like a fish lens, and also start to see weird jagginess. So don't go crazy. I'll just keep it something like 0.2, minus 0.2. Usually you would like to use the lens profile or ST map coming from layout, but for now we are just manually faking a little bit. Also, as the last part of lens effects, let's add defocus onto the camera. It's actually already happening, and also when it comes to defocus, it's usually disable defocus and add it in back in Nuke. But when you have some like half transparent object like smoke or particles or something like that, it's better to add defocus in DCCs. So let's go Cine Camera Actor for focus. Focus method is manual. It's actually already happening like I said. Click Draw Debug Focus Plane. Okay, it's really far away. Let's click this character here. So whatever in pink is out of focus. Let's go back to the front frame. This is cool. I want her to be in focus. Also, we can change the aperture to be lower to have more bokeh. But having strong bokeh make things a lot smaller and make it like a toy. So for me, 2.8 is good enough. Again, subtleness is the key. So let's go back to focus, and we're gonna keyframe this focus distance. Hit this add keyframe for this property. So once you hit that, you see manual focus distance is keyframed in the sequencer. So as we go to the end, or when we start to see the main building, I think we should add a rack focus, and it started focusing on the building. So I'm gonna click the building again and hit the key. So slowly we're gonna add the rack focus, maybe a little bit later, something like here. Yeah, and let's turn off debug plane. It's a bit hard to see, but now we added the rack focus. Finally, right before rendering, we should add footprint of her. I think it's kind of weird to not to see any footprint of her on the surface. So let's fake that with decal. I will go in natural sublevel. Let's go to Quixel Mega Scan. I'll turn off Niagara for now. Okay, let's select decals, search for footprint. I think we can utilize this one, snow footprint. Sign in if you haven't, and then download it and hit export. Decal is cool. You can drag and drop into the scene. It's like a sticker. You can overwrite the material onto the static mesh as long as it's within this bounding box. Right now it's square, so it's kind of weird, but let's squash it. And you start to see the footprints appearing on top of the snow surface, which is absolutely crazy cool. Be careful not to overwrap this box on top of her, so that you will start to see this whiteness coming. You want to make it flat and add it just right above the snow surface, so that you wouldn't see the snow projected onto the static, projected right above her. Just want to project right onto the snow. If you go very crazy, you have to animate the mask inside a material to start the footprint revealing and adjust the timing as her foot goes. But for now, it's so the snow is over there is so bright and it's so hardly visible. So I would just keep this one as a hint. You don't have to. I wouldn't worry about it much. So let's start rendering. In order to render, we're gonna use movie render queue, which can be triggered by here. But right now, it's not actually triggered. So you have to go settings. There are a few plugins that I want to install. So go plugin, type movie render queue. I will also enable this when you are doing comp outside of Unreal Engine, but for today I think it's fine. Also type Apple ProRes Media. By default, if you don't have this one, you cannot export any movie file. I mean, obviously in the production, you don't want to use movie file. You want to just use you want to just use EXR sequence. But again, for this particular case, we're gonna use ProRes to preview quickly. So turn them on and restart now. Save everything. So go back to the level and sequencer and let's start rendering. We will encounter some problem to improve. Let's render the first pass. In order to use movie render queue, hit this one, and this is the UI. By default, it will ask you which persistent level you want to render from and which sequencer you want to use to render. And this is the job list. You can technically have multiple jobs for, if you have like multiple shots for a sequence, you can have per shots and you can change the level you are in as well. But for now, it's just one shot. Sequence map is correct. Let's go settings. Let's change things. By default, it's exporting JPEG sequence. We're gonna use movie file, so delete that. Use Apple ProRes. Don't use ProRes 444XQ. It's gonna be super heavy. For this purpose, ProRes 422 or 422 LT is more than enough. Keep default rendering. For output, we can use a variable to select your desired folder. We're not gonna use default path. You can select the folder that you want. So in this case, this is the Unreal project folder, but I wanted to render outside of project folder, so I created it called Unreal Render, and I'm gonna select this one as a parent output directly. But also, we can add more variable inside of this Unreal Render folder. Inside of render folder, I want to create the shot number, and inside of shot number, I want to create subfolder with shot number and version. Go Unreal Render / brace. This is how you add variable. I'm gonna add job underscore name, which will take the name of here, and inside of job name, brace version, and hit accept. You can try clicking this output. It created the subfolder under Unreal Render, the job name, shot name, and the version subfolder, and it's pointing that directory, which is cool. File name format can be sequence name. It's currently the same name as job name, which is fine. Both of them are fine in this case. You can alternate however you want. Sequence name dot, I want version. And since this is movie file, we don't need frame number, just version. And that's it. Output resolution is 2K, which is fine. And if you have auto version click, this version number will automatically increase. But if you don't have it, you can manually change it. Hit accept. Alright. And finally, we can save these settings because every time you close and open Unreal, these settings will be gone. So let's save these settings by hitting save preset here. I will create here tools folder. I would just name this GTC movie primary pipeline primary config P001. Accept, this is fine. This one right here is your saved queue. For example, if you have combination of multiple shots, let's say you have shot from 1 to 10, and you can save this queue as shot 1 to 10. And if you have more than that, you can change the combination, and you can save that queue here. So you don't have to add shot every time here. You can load it from the saved queue as well. So that's a little bit of trick there. But we don't have many shots. We only have one shot, so we're not going to use this. And before rendering, as a little tip, if you hit render, meanwhile you have this viewport open, essentially Unreal is running 2 instances, which is computationally heavy. So I'm gonna open new level, empty level, create. I'm not gonna save this level, but just not to have something open in the viewport. Then we can render. So hit render. Okay, immediate problem that you can notice is that the Niagara particle start blowing away when the rendering starts. Instead, we want the particle to be already started by the time we started hitting render. So how can we approach that? You can actually set the timing of Niagara particle to start inside a sequencer. So let's drag sequencer up, go into Niagara effects. I'm gonna create a folder, call it Niagara. You can change the color if you want, and drag all the Niagara particle into this folder. And then on top of that, select one of the Niagara particle, click this plus button, Niagara components, hit Niagara components, plus again, Niagara system life cycle track. Set this system life cycle to desired age and drag this guy to the left. Copy those two tracks, apply, paste it onto the rest of the particle in the sequencer and Ctrl B. So now these guys are added inside here. Immediately the Niagara particles stop moving, but as you drag the timeline, it starts moving, and when you stop the timeline, well, it glitches a little, but it stops. So that's how you can control the Niagara particle inside of sequencer. And let's render again. So let's hit sequencer again, create new level to get out of here, to render. So hit render again. It's gonna be saved as version 2 automatically, and it's gonna be inside of subfolder version 2. So I am playing version 1 and version 2 all together. In version 2, the Niagara particle is already there. And on top of this, maybe what we can do is increase the render quality a little bit by A, applying the anti-aliasing, and also B, increasing the lumen scene quality. So let's do that. So let's go to post-process here and type lumen. Let's change the lumen settings. In global illumination, make sure you're using lumen as a method. And first thing I would change is final gather quality here. This is going to update the number of rays shooting from the light source. This one is especially useful when you have like dark scene. Probably not much in this scene, but if you have like lower final gather quality, probably you may be able to see some kind of artifact on the shadow area, and as I increase, it's pretty subtle, but in this scene, by increasing final gather quality, your light source will shoot more rays. So in this case, I would just put it 2. And next thing, let's go into lumen scene. The things I would change is max trace distance, or if you decrease this, you got white. This is distance mesh field. It's kind of like a proxy geometry. By increasing this, the detailed proxy geometry will start to kick in. So I want to make sure to cover the scene by increasing this max trace distance. Then make sure to use that fallback mesh in here. Also, I would like to increase lumen scene lighting quality. If you decrease, you start to see immediately a lot of flickers happening here. By increasing, you essentially going to increase the quality of lumen scene. This one is particularly useful for refraction. Probably not much in this scene, but something to add. 2 is enough. You can maybe even go 4 on both of these. Other settings are not affecting in this time, so I would just skip that. On top of that, let's add anti-aliasing when rendering. So go to settings. Let's add anti-aliasing. So on top of that, I'll just click override anti-aliasing and temporal sample count 16. And just to make it even more better, I'm gonna add console variables. This is the same thing as here, but you can trigger this when you are using movie render queue. I'm gonna add this, type r.screen percentage, and let's make it 150. So it's going to render the resolution 1.5 times bigger, but shrink it down to HD size of image. By doing so, it actually results in increasing more crisp render quality. And I'm gonna actually save these settings, save this preset, accept. So let's get out of this level and render. Congratulations! You just made it to the end. As we wrap up this comprehensive tutorial on creating cinematic shots in Unreal Engine, we cover so much aspect and your dedication and patience has been the backbone of this learning experience. I am very, very thankful for your choice to join this course and for the opportunity to serve such a skilled community at Norman Workshop. It's been an honor and privilege. Until we meet somewhere again, keep creating, keep exploring, and I hope this course was at least a little bit beneficial to you. Once again, thank you so much for watching this tutorial, and see you somewhere next time.